I'd like to go over our 4 basic common rules of exponents and then go over the most common misconceptions that students do with the rules of exponents. So the first thing, we're actually only going to cover 2 rules of exponents. We're going to cover the product rule, and we're going to cover the quotient rule. Now, last chapter, obviously, ladies and gentlemen, we did a lot of this, right? So you guys should be familiar with the product rule. But I would recommend you writing it down so we can explain it from other ones. You guys know that x to the m times x to the n is equal to x to the m plus n. The way I described this was when you are multiplying 2 powers, or 2 exponents, as long as they have the same base, you add the powers, right? And we've done plenty of those. The quotient rule was kind of the same thing, but for dividing. Whenever we're dividing 2 exponents with the same base, then we simply subtract the powers. OK, Tyler? Now, the next thing is, let's go ahead and talk about some of the misconceptions. You guys are pretty familiar with this, right? Yes? Now remember, though, this only worked, and I said it, this only works when you are multiplying powers with the same base. So for instance, x to the m times y to the n is just equal to x to the m times y to the n. Okay? You can't do anything. You can't combine them if the bases aren't the same, right? They just remain. It's just the same expression. You can't do anything. And that would work the same for the quotient. Now let's get into sum and difference. Okay? So how do we add exponents? Yes?
If you have 2 different numbers, you multiply them. So wouldn't it be x, y, and n?
X, y, m, n. Well, let's look at it. If I did 3 squared times 2 cubed. OK? So what are you saying you do? You'd multiply x, y, and then what would you do with the powers? Add them? I'm just saying. Just tell me what it thinks about. You would think about this would be multiply those and add the powers. So if you did that, you'd have 3 times 2, which is 6 to the 5th power. Well, that's a big number, right? Now, do we know the answer to this? Yeah, we should. 3 squared is 9. 2 cubed is 8, which is 72. 6 to the 5th is definitely not going to be 72, right? That's going to be some huge number. So that's why my trick, though, is whenever you guys get confused with these, I always like using 2 and 3s. And you can basically prove everything with using 2s and 3s, because those you guys understand the squareds and taking the square 2, 3s, and 4s, I'd probably say. All right. So now let's get into sum and difference. And we're going to go back again through these rules. But just remember, whenever you're applying the rules of exponents, the main important thing I have you guys remember, you have to have the same base, right? You can only multiply x squared times x to the 5th, right? So now let's look at the sum and difference. If I'm adding 2 powers, I not only have to have the same base, I also have to have the same power. Right? X squared plus x squared. They both have x, and they both have squared. So x squared plus x squared is 2 x squareds. So when you're adding and subtracting, not only do you have to have the same base, you also have to have the same power. So I really want you guys to remember that. That's very, very important, because what do students start to do? They say, oh, x squared plus x cubed. No, you guys cannot combine them if they have different powers. Those are what we call not like terms, right? You can't add x squared and x cubed. So that just remains the same. And the other thing is, you can't add x plus y, right? Yes? So in the same respect, even if they have the same power, you can't say x squared plus y squared is something, because you can't. How are you going to determine what the base is? So x to the m plus y to the n is just, again, exactly the same. OK? There's no combination. So what I want you guys to understand is when you're doing sum and difference, the rules are different for sum and difference than they are for product quotient. For sum and difference, for you to combine them, you have to have the same base and powers. But for product, you just have to have the same base. Also note, when I'm adding, what am I actually adding? When I'm adding these two, what actually am I adding? We actually have little coefficients back over in here. So in the same respect, if I was going to do 2x to the fourth minus 5x to the fourth, that's negative 3x to the fourth. Okay? So you're actually adding and subtracting the numbers in front of your exponents. Okay? That make sense? Okay.